All right, now let's talk about phase shift. Now, phase shift is just a horizontal shift. That's all it is anytime you're working with a sine or cosine, that's what that word sinusoidal means. It means either sine or cosine. It's the horizontal shift. So you would find this by, if you remember, horizontal is always on the inside, and you would solve it for x, which means here, instead of having, if you were going to take this, any bx plus c, you would set it equal to 0 and solve. So you would first subtract the c, so you'd have negative c, then you would divide by b. So you'd have negative c over b. And that's what they have here. Now they just say the absolute value just because it doesn't matter if it's a wave, which way you shift it, right or left. But I'm just going to keep it simple and do it the way you've always done it all year. Why change something you already understand how it works? So a phase shift we're going to look at this time as well. So let's start with amplitude. Amplitude is found where? It's found at the very beginning of the function. So the amplitude talks about its height and lowest point, which is the vertical shift, or vertical stretch, or shrink. It's given here. This is my amplitude. So my amplitude is 2. Next comes the period. Now remember your period, you use the b value, which is the horizontal stretch or shrink. So you're going to take 2 pi, because that's the length of a normal period, and you divide it by this value. That's my b here, so I'm going to divide it by 5. I cannot reduce that, so that right there is my period. Next, it says find the frequency. Now if you remember, frequency is just the reciprocal of the period. That means it would have 5 complete cycles every 2 pi. Now if you reduced it, you could figure out how many cycles it has for 1 unit if you got an exact value. That's what frequency would be. All right, and then finally the phase shift. Now this is the horizontal transformation. So a phase shift, again, is like a horizontal shift. It would be equal to, what you do is you solve for x here. So all this, we're going to solve for x. So it would be negative pi over 4 first, because you're solving for x. It's kind of like you said equal to 0. That goes across, and then you divide that by 5. Now I'm going to simplify this. And so how do you simplify a fraction to being divided by a fraction? Well, if you remember, you take your fraction. I don't know why I use approximately. Let me use that. This is going to be equal to negative pi over 4. You take your the numerator, and you, instead of dividing by the denominator, you flip it and multiply by the reciprocal. So instead of dividing by 5, we're going to multiply by the reciprocal, which is 1/5. That means this will be shifted negative pi over 20. So you can shift it negative pi over 20 to get the exact location. So this is a sine function. So sine starts here on the origin, and it's been shifted left, pi over 20 units. That's how far left it's gone. Don't get confused here. These 2's and negative 2's, that's talking about the amplitude. It has a height of 2 and a depth of negative 2. All right, so that would be how the function looks. Let's see here. The period, what does the period refer to? It would be a complete cycle. So from highest point to highest point, something like that would be 2/5 pi. 2/5 pi. You can see it that if it starts here at 0, almost at its peak, then 8 pi over 20, which if they simplified that, what number goes into 8 and 20? 4 does. How many times does 4 go on the top? That is 2 pi over 5. You can see that that is, in fact, a complete cycle from here to there. 2 pi over 5. So we did it correctly. Now you can go ahead and try this one.